The next type of mechanical comparator is the Johannson Mikrokater. Okay, again this is one of the forms of or another type of mechanical comparators. Okay, we will discuss it one by one. So it works on the principle of a bottom spring then spinning on a loop of string, like in the case of the children's toy. Okay, generally you may have seen the toys. Okay, so in the toys what is there, so you will have to just give the input to the toy, so that the internal arrangement in the toy, which will have the multiple linkages, then it will have the springs. Okay, then it will have some metal coils over there. Okay, so those springs and metal coils will gain energy as you put or as you rotate the key of the toy. Okay, and as you release the key of the toy, so it will, or the toy or the energy stored in the springs or energy stored in the metal strips, that energy will release. Okay, and the toy or the mechanism of the toy, it will work. Okay, so this is basically similar to the toys of the children. Okay, so it is employed, or it employs a twisted metal strip. Okay, and any pull on the strip causes the center of the strip to rotate. Okay, in the next slide I will show you the diagram of this Johannson Mikrokater. Okay, it is very much similar to the, or its mechanism is very much similar to the toys. Okay, so the next point, a very light pointer made up of glass tube is attached to the center of the twisted metal strip. Okay, so a very small shaped or a very light in weight pointer, which is generally made up of glass tube, or which is a glass tube which is mounted on the center part of the this metal strip or twisted metal strip. Okay, the measuring plunger is on the slit washer and transmits its motion through the bell crank lever to the twisted metal strip. And last point about this, so the other end of the twisted metal strip is fastened to the cantilever strip. Okay, so you will see the diagram. So by looking at the diagram you will be very much clear about how the mechanism of the Johannson Mikrokater is. Okay, so it is the overhanging length of the cantilever strip can be varied or adjusted, and the magnification it can be varied to adjust the magnification of the instrument. Okay, so it is adjustable cantilever length or cantilever strip is there. Okay, so if you want less magnification, then you will have to less or more magnification, so you will have to adjust the cantilever strip. Okay, so length of the cantilever strip, I will show the diagram in the next slide, so that you will get a clear idea about this. Okay, the longer the length of the cantilever, the more it will deflect under the pull of the twisted metal strip, and less rotation of the pointer is obtained. Okay, so if you want a very precise or less rotations of the pointer, so you will have to increase the length of the cantilever strip. Okay, so this is the photograph of Johannson Mikrokater. Generally over here this is the plunger. Okay, then this is the spindle, and over here you can see the scale. Okay, So the scale is generally employed for getting the accurate results, and a pointer is there. So pointer will show you how much is the exact reading. Okay, and this is the holding for holding purpose. This covering is provided. So this is the schematic diagrams of the Johannson Mikrokater. Okay, so over here you can see, so this is the twisted metal strip. Okay, so the spiral shape of the, or a shape like a DNA, you can see the strip is there, so that is the twisted strip. Then this is the light uh, pointer which is made up of a glass. Okay, then you can see, so this is the cantilever strip. Okay, so what is the purpose of this cantilever strip? So if we increase the length of this cantilever, so what will happen? So it will deflect more, and because of its deflection, the twisted strip, metal strip, it will deflect more and pointer will deflect less. Okay, so this is the mechanism of this Johannson Mikrokater, which is very much similar to the toys of the children. Okay, so over here you can see one plunger is there, then this is the slit washer. Okay, from or at the center of the slit washer, plunger is located, and this plunger is connected to the bell crank lever. Okay, so why this is a bell crank lever? Why is it called so? So as it is connected, you can see over here the bell shape is there. Okay, and one lever is there, you can see this is the lever. Okay, so as this plunger moves upward, so what will happen? So it will deflect, or this inner link, it will try to push that, or it will try to push this vertical plate. Okay, because of that, what will happen? The a tensile force or a tension, this twisted strip, metal strip, will get some tension. Okay, and the light pointer is mounted on that twisted metal strip. That's why the this pointer will move, or it will oscillate around the, or it will oscillate along the scale. Okay, now in this second diagram you can see, so actually this pointer, observer have to be over here looking at this part. Okay, so observer must see like this, from this side to this. Okay, so this is the scale over here, you can see. So this is the side view of the scale. Okay, so this is the scale actually, and observer have to see from this side. Okay, so that it can easily get the readings. Then this is the twisted metal strip, and the pointer is located at the center of the strip. Okay, so this is the bell crank lever, and this is the pivoted point about which the bell crank lever will oscillate, or it will translate the motion, and this point will remain pivoted. Okay, so you can see, so this is the plunger. So as we displace this plunger upwards, so what will happen? So it will basically deflect, or this translatory motion or vertical motion, it will be given to this bell crank lever. Okay, because of that, what will happen? So this part of the bell crank lever, it will move upwards. Okay, as this part moves upwards, bell crank lever is solid in nature. Okay, it is rigid in nature. Okay, so as this part moves upwards, so it will allow, or this bell crank lever's another end, it will try to go in the next direction or opposite direction, as this point is fixed, or as this point is pivoted over here. Okay, so the bell crank lever will change its shape. okay, or it will displace in the shape like this, okay. And as the shape of the bell crank lever, or as this displacement is given by the plunger to the bell crank lever, what will happen, this twisted metal strip, it will get a little tension in it, okay. And because of that tension, what will happen, the pointer will move in and out of the page, okay. So the pointer will displace and it will show the reading on the scale, okay. And observer must have or must see from this direction, okay. And then only it can observe the reading on the screen. Now this is the working of the Johannson Mikrokater. Now we will move towards its advantages and disadvantages. So advantages is, it do not require any external source of energy. As you already know, all mechanical comparators do not require any kind of energy source, or it will not require any electrical supply or main supply, okay. Or it will not even require any battery source, okay. So this is completely independent, or you can say it will not require any external source of energy, okay. Second point, it is cheaper and portable. You can take this mechanical comparator, any kind of mechanical comparator, you can take it anywhere you want, okay. All the mechanical comparators are portable and they are cheaper in rate. Then next point, it is robust in construction and compact in design, okay. Robust construction means it is very much harder. You can uh, use that instrument, or you can use that product in a very rough and tough way, okay. So that's why uh, we can say it is robust in construction, and its design is very much compact, okay. Small in small space, it can it can be, what can we say, it can be manufactured so that it can be placed in a very small space, okay. Then next is, it is simple, linear scales are easy to read, okay. The simple linear scales are there which are very much easy to read. Then last point in advantages, it is unaffected by variations due to external source of energy such as air, electricity, etc, okay. It will not get any problem, or it will not be deflected, or it will not get affected because of any external source of energy. Now moving towards the disadvantages, the its range is limited as the pointer moves over a fixed plate, okay, or over a fixed scale. So that's why its range is very much limited. Then next point, the pointer scale system used in this, it can cause the parallax errors, okay. Already we have studied what is the parallax error. So parallax error is generally it is a result if you see the scale and pointer from a very or you can say at from a different angle, okay. Generally the method to observe the readings in mechanical instruments is to just keep your eye parallel, or keep your eye in a such a way that the pointer will be exactly in front of your eyes, okay. So keeping the pointer exactly in front of your eyes and scale, the pointer will oscillate, or it will show some readings on the scale. So the meaning of saying is that the your eyesight should be parallel to the pointer. Okay, uh, otherwise you will not see, or you will not get the correct reading. Okay, the next point in disadvantages is that there are number of moving parts which creates problem due to friction, and ultimately accuracy is less. Okay, as there are many number of, or you can say there are many moving parts, so that's why the friction is one of the problems, and because of the friction loss of energy will be there, and as the energy is loosened by this instrument or by the linkages, it will not give you the correct results. Okay, so that's why accuracy is very much less. Then next last advantage disadvantage of this Johansson Mikrokater is the instrument may become sensitive to vibration due to high inertia. Okay, if we put the plunger on a vibrating area, then what will happen? So because of the high inertia, the instrument becomes very much sensitive. Okay, so these are some disadvantages of this Johansson Mikrokater. So over here you can see, or this is the mechanical comparator. Using this we can find out the, or we can compare the standard dimensions to the actual dimensions. Okay, so this was about the Johansson Mikrokater. Thank you very much for watching this video.